to define the IP design towards this case and to see what were the design thinking methods that could be used when we have a combination of different methods. In this particular case, so we're going to use a cognitive walkthrough detailing the different process steps with the swim lane and illustration, and then using the activities, environments, interactions, objects, and user classification, so the AEIOU method.
Yeah, what we here see is the cognitive walkthrough through this process we learned about in this case study. So it's in the end the different process steps. The user, this means the person in a car, experiences if he or she is entering a parking garage, finding a parking place, position the car in the right order in the parking lot, that one car is not blocking two parking lots, and in the end paying and leaving the garage. So this is the, let's say, these are between these 2 points and wanting to park till leaving the garage. These are the different process steps represented in this so-called cognitive walkthrough. And if we go on the next slide, we see this different, in this case, for 3 of these process steps, which are the 3 green columns, or columns with the green headline. In this case, look for assigned parking bay. The first step, park the vehicle, the next step, and then feedback for correct parking position. This is then after parking the vehicle, the next step. So these 3 steps are a part of this chain I showed you on the last slide. If in this case now the AAEOU method, Sophia already explained, gets adapted, and this works in a way that for each process, this let's say for let's say perspectives get applied. For example, let's take the last process on the right column, feedback for correct parking position. This is an activity, so this is for the A. Yeah. Then the E for the environment. The environment in this case means, let's say, the environment of the activity. So what's in which context this activity is taking place. So if we are speaking about the feedback for a correct parking position, so this means the check whether the car is placed in the right order in the parking lot and not blocking two lots, but just one. The environment is the acceptable vehicle positioning, which is required. In the next line, where it's about the objects, please go back. Please go back. In the previous slide. No, slide 3 exactly. In the third line, which is about the objects or system components, the different objects with which the with which the user is, let's say, interacting are mentioned. So here in this case, in the right process, it's the modular cell, so the parking bay, and it's the sensors with which the user is interacting. And if we speak about the user, this we see in the 4th line, user groups. It's all kind of user. So it's doesn't matter whether it's about an average parker or a parker of a small car or of a SUV. So this process is applying for every of these user groups. And what regards the interaction in the 4th line, on the bottom of the slide, in the right column, we see for this feedback process, it's about the sensor check about the correct positioning, which is, let's say, relevant for this process step, and the transmission of the occupancy status to check whether the car is in the right position. And this AAEOU method can, in the end, be applied for every process step in order to get a basis for later on developing IP, which protects the customer benefit generated here.
So, very central part of the IP design is when you are identifying the inventions in a complex situation like all the circumstances around parking a car. It's very important to find the different customer benefits and to find the benefits for all these activity steps in this plan. And here you have a list of tasks that can be considered non-trivial, that you have to have use creativity to define and to becoming a central part of the inventions. And you, for example, you have the to record a user's parking preferences, to evaluate the situation for the occupancy, for the direction of the users into the different parking bays, availability, and also automatic computing of the parking fees. And there's then a need to further evaluate and specify the identified uniqueness environments, as was mentioned. Next slide.
So then we go to isolating invention cores. So what are invention cores? These are basically the fundamental principles behind the approaches, and this to achieve or obtain the desired goal, these are to be implemented and identified. How can this be achieved? By parameterization of the task, by transforming a real-life task into a generic technological task, and then identifying the next steps in order to deliver the task from technical perspective. So what example we have taken here is to direct users into the parking bay. Real-life task is parking a car in a parking bay, and this can be achieved by identifying the technological tasks which could be patented. Like there are patents on LiDAR recognition, on image identification, on connecting the radio frequency identification of a car through the infrastructure, RFID sensors, or this could also be vehicle to infrastructure communication. So these are the patents which are possibly going to cover these technological aspects. So identifying a free parking space or comparing the parking space with vehicle dimensions. For example, an SUV may not fit into an available parking space on a level. So maybe a comparison is made that that sees there's a possibility of parking on another car level, parking level, which would enhance the qualitative experience, which would make the process of parking easier. There are other technological tasks like determining the ideal position, the orientation, whether reverse parking is possible, or what orientation the car should be parked in. Then marking the customized parking space, and then provide assistance with the parking process. Again, this could be achieved by vehicle to infrastructure technological patents. So the key point to consider here is that the invention cores must not, FTO is also a point to consider, but before applying, of course, one has to check if there's a prior art or not. So invention cores must be checked against prior art. So that is basically the process of isolating invention cores. Thank you.
And we close this wonderful presentation on a beautiful Friday evening with a simple example, basically to show how we can further identify alternative technical solutions by effectively breaking down certain technical elements into further attributes. I mean, for me, I'm not an engineer, but I like to think around it as, basically thinking about the language model or the programming model that you would teach a machine and how you would dissect it from a logical level or from a decision tree into the different technical elements. Actually, get a logical baseline for you to think around what could be technical alternatives to be driving for, what could be technical elements to eventually develop and to protect and to use. Thank you very much for listening, and back to Tobias, I guess.